Hello everyone. Today we will be solving the question parking lot on Codeforces. So let's first start by reading the question. To quickly hire highly skilled specialists, one of the new city companies made an unpredicted move. Every employee was granted a car and an employee can choose one of the four different car makes. The parking lot before the office consists of 2n minus 2 parking spaces. Unfortunately, the total number of cars is greater than the parking lot space. Furthermore, even amount of cars of each make is greater than the amount of parking spaces. That is why there are no parking spaces on the parking lot ever. Looking on the straight line of cars, the company CEO thought the parking lot would be more beautiful if it contained exactly n successive cars of the same make. Help the CEO determine the number of ways of filling the parking lot. So now we are given four cars: Aston Martin, Bentley, Mercedes Maybach, and Zeprozets. Okay, so let's first understand the question completely. So in this question, we are given n, that is the number of, okay, one second, yeah, okay, n, that is the number of cars we need to have in a successive cars of the same week we need to have successively. Okay, the other thing we have is the number of parking lots we are given. Number of parking lots we are given is 2n minus 2, and for the case of n is equal to 3, it will be 2 into 3 minus 2, which is 6. Okay, so now first let's just understand the question. We are given two things. First is n, that is the number of cars we need to have successively, and the other thing we are given is the number of parking lots, that is 2n minus 2. Okay, now in this question, let's first start by plotting it. Oh, I'm sorry, I've written it 2 6, it is 4. Okay, 4. Okay, so let's just make four parking lots. These are our four parking lots. I will be starting with A. So we are occupying three spaces with A because we have to have three cars of the same make successively. So we are giving the first three places to A. Now this place can be either be B. Okay, now this place can be any other car. Okay, first we have to understand this. A cannot come here again because then the number of successive cars will become 4. Okay, so here either B, C, or Z can come. Okay, so here we will give A again. I will make all the cases for the first time. Okay, here C can come, then A again, and A again, and here Z can come. Now after this, let's just make 4 dashes again. Now all the cases for the first 3 are completed. Now we will be moving this 3 ahead. Now A can come here, A and A here. Now as you can see, I have moved it ahead, but still the 3 of them are together because we need to have 3 successively. Now here B can come. If A is here can C, and here comes Z. Okay, so the total number of, oh, I'm writing C here, yeah, it's M, sorry, I'm really sorry, it's M. Okay, the total number of cases is equal to 6. Now if we replace A with B, the total number of cases will be 6. If we replace B with M, the total number of cases will be 6, and if we replace M with Z, the total number of cases will be 6. So the total number of cases will become 6 plus 6 plus 6 plus 6, that is 4 into 6, which is equal to 24. Okay, and we can see that this is our first case. Now let's go ahead and understand it a bit more clearly. For this we will be using n is equal to 4. Okay, now on n is equal to 4, what will be the value of 2n minus 2? 2n minus 2 will be 8. 2 into 4, which is 8, minus 2, which is equal to 6. Okay, now For 6, let's just make the parking spots 1, 2, 3, 4, 5, and 6. Now this time I will be using the methods of permutation rather than displaying each and every single case. Okay, so if we have the n equal to 4, that means there can be 4 consecutive values of n. Oh, sorry, there should be 4 successive cars. Now see, we are taking these 4s are the same. Okay, we are considering these 4 are the same. So this will equal to, I am putting a 1 here to represent that these 4 are the same. Now what cars can come here? Here either B can come, M can come, or Z can come. Okay, we are considering A is here. Okay, so here B, M, and Z can come. So here there are total 3 cases that can happen. Now the total cases that can happen here are, now this is important. Okay, in the question we are told to have n successive cars, but there is no one says that this car cannot repeat again. Okay, so here the total number of cases can be either a the total number of cars that can come here either B, A, B, M, or Z, all 4 of them. So there will be 4 here. Okay, this is first case of this one. Now we take another one, 1, 2, 3, 4, 5, and 6. Now considering these are 4s. Okay, so here can be 3, because if we put A here again, then it will become n plus the number of successive terms will change. So here will be 3 and here will be 3 again. Okay, now we do it again for it, 1, 2, 3, 4, 5, and 6. Considering these 4 as A's, this can be 3 and this can be 4. Now what do we see in this part? We see that 3 will only come at the places that are at the point of intersection with the n successive cars. Okay, so which can at most come twice, or at least will come once. Okay, this is what we know from the observation we have seen here. Okay, now if we have to make it in a more generalized manner, let's go for another case, n is equal to 5, in order to generalize what we have learnt. Okay, now okay, or we can just go for any n terms. Let's just go for n is equal to 5, and but I will explain it through n terms. Okay, the total number is 2, the total number of parking lots is 2 into 5 minus 2, which is equal to 8. Okay, now there's 1, 2, 3, 4, 5, 6, 7, and 8 parking lots. Now I will ask you the first and very important question that you should think about. How many total cases can there be? Okay, now no, let's not think about how many total cases. We know that this part is equal to n. Okay, this part will take n parking spaces. So this part what will this part be equal to? We know the total is 2n minus 2. The total is 2n minus 2, and this part here is n, so we will subtract n from it and we will get n minus 2. Okay, so this is equal to n minus 2. So there are total n minus 2 parts. Now the other thing that I want you to think is, okay, let's just start with this now. Okay, so here this part will be 3, this will be 4, and this will be 4. It's understandable now, I guess, because this 3 is this part is in intersection with the n successive cars, so that's why we are given a 3 here. Now let's make it again, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and taking 1, 2, 3, 4, and 5 from here, this part will be 3, this part will be 3, and this part will be 4. As you can see, the number of spaces left are still the same. Okay, So the number of spaces left do not change ever. Now we do it again, 1 2 3 4 5 6 7 and 8, and we go from here to here. This will be 3, this will be 3, and this will be 4. 1 2 3 4 5 6 7 and 8. Okay, and this time we are going from the last, 1 2 3 4 5. This part will be 3, this part will be 4, and this part will be 4. Okay, I guess it's understandable to everyone why we put 3 here, here and here, and why we are putting 4. Okay, so now the next thing we need to understand is how many times will this thing happen. Okay, for 5 it happens 4 times. Okay, but we cannot just take how many times it happens for 5 and use it for a generalized formula. We have to think about why this happens. See, we can see there are total of n parts over here. Okay, and how many are free? N minus 2. See, so in every move it will move one step ahead. It will move one step ahead, then it will move one step ahead, then it will move one step ahead, until unless it gets to the end. So how many times will it take to move n minus 2 steps? How many moves will it take to move n minus 2 steps? It will take n minus 2 moves. Okay, now n minus 2 moves will be made, but we have to consider the first condition where it starts from the first block, which is, so we have to plus 1 in this, and we will get n minus 1 steps in total. So there will be total of n minus times this thing happens. Now I want you to think about another thing. How many times will there be 2 points of intersection? Or okay, rather let's not think about 2 points of intersections. Let's think out at what times there will be only 1 point of intersection, like here or here. As you can see, one point of intersection can only occur when the other end is at the either at the start or at the end. So out of this n minus 1 times that this thing happen, 2 times there will be 1 point of intersection for 3, and n minus 3 times there will be at 2 times there will be 1 point of intersection of 3, and n minus 3 times there will be 2 point of intersection for 3. Okay, here there will be 1 point of intersection, and here will be 2 point of intersection. Okay, now what we have to do, we have to think and generalize a formula and be able to find this. Now first we have to think about that we have total of n minus 1 cases. Okay, now in these cases, what is the power of 4? Okay, in n minus 3 cases, in these n minus 3 cases, there are 2 3s. Okay, how many 3s are there? There are in these cases. Okay, first let me make a line here, and okay, in these n minus 3 cases, the number of 3s we have is equal to 2. Okay, and how many parking lot spaces are there in total, including how many parking spaces are there in total, excluding the n successive cars? It is equal to n minus 2. Now out of these n minus 2 spaces, 2 of them are filled by 3s. So how many of them will be filled by 4s? It will be filled by 4s as n minus 2 minus 2, which is equal to n minus 4 spaces. Okay, now I think you all know that we are multiplying these terms in order to get the answer. I think all of you know that already. I don't have to tell you this because I am considering all of them as ones. So I think you all know that, because this is how we use in permutation and combination, and if you have studied it, you will be able to understand it. Okay, if you haven't studied it, I really prefer you to go study that first, because it is really important for this question. Okay, now after this let's think out these cases where there is only one 3. So the number of 3s in there is equal to 1. Okay, and the number of 4s here will be n minus 2 minus 1, which is equal to what? N minus 3. Okay, so what is the general formula we have? What do we have here? Here we have what? There are two cases in total, so we multiply it by 2 first. Then what? 3 raised to power 1 multiply by 4 raised to power n minus 3. We see it here because there are total of n minus 3 number of 4s. Okay, this, and we have to add it with these cases, because either this will happen, see, either this will happen, or this will happen, or this will happen, or this will happen. And when we use the word or, okay, I will just tell you one tip here. Okay, if we use the word or, it means addition. Okay, whenever we use the word or, it means addition. And whenever we use the word and, okay, whenever we use the word and, it means multiplication. Okay, this is a basics that you will learn in permutation and combination better, but just something that you should know. Okay, now see, either this will happen, or this will happen, or this will happen, or this will happen. Okay, now we have first taken these two cases, this case and this case. Okay, that is why we have multiplied it by 2, because either this case will happen or this case will happen. It's just that this formula, this formula for both the cases are the same. That's why we have multiplied it by 2. Okay, now on this part, we have total of n minus 3 cases. How many cases do we have? N minus 3. So we multiply this with n minus 3, and 3, there are total of two threes, so we will multiply with 3 raised to power 2, and we will multiply it with 4 raised to power n minus 4. Okay, we get this. So this will be our answer. Now this is not the complete answer. There is one more thing. We have only found the answer for 4s, for A. Okay, for A. If we need to get the complete answer, we need to multiply this whole digit with 4. After this, we will be able to get our answer. Now, in order to code this, we will first, let's see the maximum value of n. Okay, the maximum value of n here in this code can go to 30. Okay, we don't have to worry that much about time complexity because n is only going to 30, but what we have to worry about is 4 raised to power, see, the maximum will be 4 raised to power 27. It can go above the value of int. Okay, it can go above int, the range of int. Okay, I guess the range of int is around 10 raised to power 12, I guess. That's it. But okay, but 4 raised to 27 can go above the range of int, therefore we have to use long. Okay, we have to use long int just for safety. Now let's start with the code. Okay, so here we are given, okay, I think I should have, okay, let's start with this. Now here I have used two things. First is this is the formula that we have written. Okay, this is the formula. This program here, I think I should zoom it. How can I zoom it? Okay, I'm not sure how to zoom this right now, but it's okay. I guess it's visible to everyone already. So this part here is the binary exponentiation. If you haven't studied binary exponentiation, I will drop the link down in the description. You should study this. In this in binary exponentiation, you can calculate the power till n in O of log n complexity. Okay, log n complexity, which is really fast rather than going for O of n, because usually it will take O of n, but we can go for O of log n. Okay. Now here we have taken, I think I am not explaining this part, you will be able to study this in the description, or if you want I can make a video on this. Now this is a pretty simple code. We just have to apply this formula and we have to just calculate the power. You can calculate it normally too in this case either, because n is very small here, but when you are but if n goes to power of 10 raised to power, you say 8 or 9, then you cannot solve it using the normal ways, then you have to use this method. Okay, so first let's, okay, you see I have already computed the answer for, okay, what is this, yeah, yeah, now I guess it's right, it does work now, yeah, it is giving 24 here. If I put 4 here, it will give, I guess, oh my god, what is wrong with this one? It gives, what happened? Oh, quick notes. Okay, it is wrong. Okay, oh, so I'm sorry. I was just sorry, I just pressed the wrong button. Yeah. Okay, now I think it should work. Okay, what is wrong with this? I'm not sure what is happening right now. Okay, let me just do it somewhere else. Okay. Yeah. Okay. So let's just take 4 here. Yes, we get 132, and we can just check it over here what you are getting. Okay, see. Okay, let me just zoom it out for you a little bit. Here we were getting 3 into 4, which is what is equal to 12. Here we were getting what, 3 into 3, which is 9, and here we were getting 12 again. So if we do the addition, 12 plus 9 plus 12, it is equal to 33, and we have to multiply 33 with 4 in order to get our answer, which is equal to 132. Okay, so you can see we are getting the right answer here, and okay, you can check it for 5 here as well, but I guess it's not worth it now. Okay, sorry, I'm gonna check it over here. We can go for 5. So, okay, let's go for 6, and just in order to check if it is working for any time complexity, let's just go for the biggest value, that is 30. Okay, we are getting our answer, so it is working now. I have just seen my program, and I think there's a few changes you can do. Rather than computing this, we can either go and compute just res1 by 4. This will also work. This is I think a bit better way. Rather than computing it again, you can just compute it in O of 1. Okay, or you can just change some things here. It won't make that much of a difference, but I guess it's worth it. Okay, now, yeah, so this will be all for today's video. If you want any specific question to be solved, you can comment it down, and I will be giving out more videos soon. Thank you so much.